Hi, and welcome to the TranslatorsCafe.com channel. In this video, we will talk about time, a topic covered in the TranslatorsCafe.com unit converter website article. We will discuss the units and devices used to measure time. Finally, we will discuss the time zones and the coordinated universal time. To open the time converter, click on the link below. This video explains in detail how to use the TranslatorsCafe.com unit converter. So, what is time? What are its physical properties? Time can be viewed in two ways: as a mathematical system designed to help with better understanding of the universe and the progression of events, or as a unique dimension, part of the structure of the universe. In classical mechanics, time has a constant rate of change and is viewed independently, not in relation to other variables. Einstein's theory of relativity redefined time as having a variable rate of change for the objects in movement relative to one another. This phenomenon is called time dilation and can be observed at speeds near the speed of light. It has been experimentally proven in the Hayfel-Keating experiment, where 5 atomic clocks were synchronized. One of them was left stationary, and the rest were flown around the Earth and back on commercial airplanes. When the experimenters compared the time, they found a disparity between the stationary and the traveling clocks, as predicted by the theory of relativity. Increase in both speed and gravity slowed down time. So, how is time measured? Clocks measure the physical movement of time, while calendars consist of abstract systems that represent longer time intervals, such as days, weeks, months, and years. The shortest unit of time is second, which is an SI unit defined as the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the caesium-133 atom. Mechanical clocks generally measure cyclical events of predetermined length, such as pendulum swings, calibrated to oscillate every second. Sundials track the movement of the sun across the sky throughout the day and use a shadow to display the passage of time on a dial plate. Water clocks, which were used from the antiquity and throughout the Middle Ages, measured the time by the flow of water between several vessels, just as the hourglass uses sand and other similar materials. A San Francisco-based Long Now Foundation is designing a clock, the clock of the Long Now, meant to survive and remain accurate for 10,000 years. The project focuses on creating a simple, transparent, and easy to understand and maintain design with parts made from non-precious materials. Currently, the design supposes human maintenance, including winding. It uses a dual time tracking system of an inaccurate but reliable mechanical torsional pendulum and an unreliable, due to the weather, but accurate lens that gathers sunlight. Atomic clocks are currently the most accurate time-measuring devices, used to ensure accuracy during radio wave broadcasting, in global navigation satellite systems, and in global time distribution services. The atoms used in these clocks are slowed down with lasers and cooled to the temperature close to absolute zero. Time is measured by measuring frequency of the radiation produced by electronic transition in atoms, and the oscillation frequency is dependent on the gravity and the electrostatic forces between the electrons and the nucleus, as well as on the mass of the nucleus. Currently, the most common atomic clocks use caesium, rubidium, or hydrogen atoms. Caesium atomic clocks are the most accurate long-term, with the error of less than 1 second per 1 million years. Hydrogen atomic clocks are about 10 times more accurate for short periods of time, up to a week. Other measuring devices include chronometers, which are precise enough to be used for navigation. They determine the geographic location based on the position of the stars and the planets. Today, some of the marine professionals are required to know how to use a chronometer in order to become certified. And chronometers and sextants are kept on a number of vessels as a backup system. But global navigation satellite systems are more commonly used. Globally, the Coordinated Universal Time, UTC, is used as a universal timekeeping system. It is based on the International Atomic Time, TAI system, which uses a weighted average of the time of over 200 atomic clocks located across the globe to calculate time. As of 2012, TAI is 35 seconds ahead of the UTC. This is because UTC adjusts to the mean solar day by adding leap seconds, due to the fact that the solar day is a little longer than 24 hours. Sometimes these leap seconds can cause problems, especially in software. Alternatively, to avoid problems with the leap seconds, some institutions, such as the Google Server Division, use a leap smear, lengthening the number of seconds preceding the leap second. Greenwich Mean Time, GMT, was also widely used until recently, but has since been replaced by UTC. GMT is less accurate than the UTC because it is based on solar day calculations, which, in turn, depend on the Earth's rotation period, which is not constant. GMT was widely used in the past. However, now UTC replaced GMT. Based on Coordinated Universal Time, UTC, time zones are formed. Time is approximately the same within each time zone. Time zones are formed so that the differences in time between them are a multiple of 1 hour. Thus, there are 24 time zones, and the reference point is the Greenwich meridian. The corresponding time zone is the zone with 0 UTC offset. When moving from one time zone to another, the number of minutes and seconds is not changed. Sometimes, time zones differ by an integer number of half hours or quarter hours from UTC. One example is the island of Newfoundland, where the local time is UTC minus 3 hours and 30 minutes. Calendars track single or multiple levels of cycles such as days, weeks, months, and years. They can be subdivided into lunar, solar, lunisolar, and other types. Our description of calendars is accompanied by the video story about 4 seasons. Lunar calendars are based on the phases of the moon, with 1 month consisting of 1 lunar cycle. A year is 12 months long, which is 354.37 days. The lunar year is shorter than the solar year, and as a result, lunar calendars are synchronized with the solar year only once in about every 33 lunar years. Islamic calendar is one such example. It is used for religious purposes and is an official calendar in Saudi Arabia. Solar calendars are based on the movement of the sun and correspond to the seasons. They're based on a solar or tropical year, which is the time that it takes for the sun to complete one cycle of seasons. For example, from winter solstice to winter solstice. The mean solar year is about 365.242 days. Because of the axial precession, which is a slow change in the position of the Earth's rotational axis, a solar year is roughly 20 minutes shorter than the time needed for the Earth to orbit around the Sun, as measured against the fixed stars. This time is known as a sidereal year. The solar year is gradually becoming shorter by 0.53 seconds per 100 solar years. Therefore, some steps may be necessary in the future to synchronize solar calendars to the solar year. The most well-known and widely used solar calendar is the Gregorian one. It is based on the Julian calendar, which in turn is based on the Roman one. Julian calendar defines the year to be 365.25 days. This is 11 minutes longer than the solar year. As a result, Julian calendar ran 10 days ahead of the solar year by 1582. Gregorian calendar was established to correct this discrepancy. some places still use the Julian calendar, including the Orthodox Church. But most countries have adapted to use the Gregorian calendar exclusively, or alongside other calendars. By 2014, there's a 13-day difference between the Julian and the Gregorian calendars. The difference between the 365-day Gregorian calendar year and the 365.2425-day solar year is adjusted by having a 366-day leap year every 4 years, except for years divisible by 100 but not divisible by 400. For example, year 2000 was a leap year, while year 1900 was not. Lunisolar calendars are a composite of the lunar and the solar calendars. They generally use the lunar phase for months, and often the months alternate between 29 and 30 days, because 29.53 is the approximate mean length of the lunar month. Lunisolar calendars adjust to synchronize with the solar year by adding an extra month every few years. Hebrew calendar is one example, where a 13th month is added 7 times during the 19-year period, a practice referred to as a 19-year cycle or Metonic cycle. Chinese and Hindu calendars are also lunisolar. Other types of calendars are based on other astronomical phenomena, such as the movement of Venus, or historical events such as the change of an era. For example, in Japan, the Japanese era calendar scheme, nengō, literally meaning era name, is used in addition to the Gregorian calendar. It refers to each year according to the name and the year of reign of the emperor in power. The new emperor's name becomes the name of the era and is taken as a posthumous name later. According to this scheme, 2013 is Heisei 25, the 25th year of the rule of Emperor Akihito of the Heisei era. Heisei is intended to mean peace everywhere. Thank you for watching. If you like this video, please don't forget to subscribe to our channel.